sampling methods, day one. Let's get the idea in our head that we are going to be doing some sampling. We're going to be sampling for experiments. We're going to sampling for observational studies. And so we need to have some strategies, some tools in our tool belt that we can use to try to represent our population as best we can. One of the arts to this part of statistics is trying to figure out what are going to be the most significant details about a given group that are going to help me make sure I account for that when I'm getting my sample or when I'm designing my experiment. And so sampling methods day one here is going to give us some tools and some ways to divide populations and some framework to give us the best idea about how to eliminate bias when we're asking questions and when we're trying to make sure we have a representative sample. So here we go. This box is going to be divided in half. And so the first thing that we're going to talk about over here under our important ideas is the idea of a stratified random sample. When we're doing sampling, the word random is a very, very good thing. That's what we want. We want a random sample. And so a stratified random sample works in this way. It splits the population into groups or strata and it also chooses an SRS from each group. How does this work? Let's say we have a big group of students up here, and I want to ask about the homecoming dance. And I identify that here are students. Okay, there's students up here. Let's say it's a group of freshmen and seniors. And so I've got this group of students, and I want to try to figure out what was their opinion of the homecoming dance. A simple random sample would just have me take out an SRS of, let's say, 10 students. And what could happen in that sample, right? So if I take out a simple random sample of 10 students, I could end up with 8 freshmen and 2 seniors. I could end up with 5 and 5, et cetera, et cetera. Is that truly going to represent the population? Well, let's just say, for example, that my students are divided exactly down the middle. And I have 50 freshmen and I have 50 seniors. And so really the representative sample would be to have 5 and 5. But if I do a simple random sample, I might end up with 8 and 2, right? And so what a stratified random sample does is it allows us the contingency to say, let me split this into strata. And let's let my strata be the type of student. And I'll take a simple random sample of 5 from my seniors and a simple random sample of 5 from my freshmen. Now, I have 2 random samples, right? So that's a necessary component. That's really, really important. So I took an SRS, but I took it from each particular group after dividing them into strata based on what I thought was important for this problem, okay? So that's the idea of a stratified random sample, is dividing my population into groups and then random sampling from each of those groups. The second way that we can do this or we can do some sampling is we could do what's called cluster sampling. With cluster sampling, we split the population again into groups based on location. Those are our clusters. And we randomly select the clusters. Here's the most important part about cluster sampling. And when you talk about cluster sampling in your answers on the AP test, when you talk about cluster sampling when you're designing an experiment, the key is you must sample everyone in the cluster. So if you ever talk about cluster sampling or they ask you about cluster sampling, you know it's cluster sampling when you randomly select a cluster and you sample everyone in that cluster. And that's the big key to cluster sampling. I want to really hone in on this idea of simple random sample right now. And in a previous video, we talked about simple random sampling. But we're going to hone that definition now. Simple random sampling in the past meant we label everybody in the group, we randomize it, and we select a certain number of people from that group. As we start to get more advanced in our ways of sampling, what we're going to realize is that sampling in a group really involves representing that group fully. Representing that group fully means looking inside the group and seeing, what is my population made up of? What are the groups within that population? And so the simple random sampling idea is going to evolve a little bit as we get a more nuanced view of what sampling looks like. So when we talk about simple random sampling now, we're going to look at choosing a group from the population so that, and this is the key here, so that every individual, that's the old version of simple random sampling, right? So we want to make sure every individual has an equally likely chance of being chosen, but also every individual and group of individuals has an equal chance of being chosen. So every individual and every group of individuals has an equal chance of being chosen. And again, to harken back to what we talked about before, steps for taking a simple random sample. We want to label, and that's 1 to n. So from 1 until you're done. We want to randomize, and the easiest way to do that is to do a random number generator, and you can represent it with those 3 letters, RNG, random number generator. And we want to select our individuals based on the numbers that came up in our random number generator. So to review that, if I have a group of students and I have 50 freshmen, I label them from 1 to 50. I use my random number generator to pick 3 numbers, for example. So random number generator 1, 50, 3, meaning 1 to 50, pick 3 of them. It spits out 7, 11, 12. Then I would go to my group and select numbers, freshman number 7, freshman number 11, and freshman number 12. So to describe that process is to say, I label them 1 to n, I random number generator to pick 3 numbers, I pick those 3 numbers from my list of freshmen, okay? Let's look at an example where we're going to be actually putting into place some stratified random sampling and also some cluster sampling. Here's the prompt. A factory runs 24 hours a day, producing wood pencils on 3 8-hour shifts, day, evening, and overnight. In the last stage of manufacturing, the pencils are packaged in boxes of 10 pencils each. Each day, a sample of 300 pencils is selected and inspected for quality. A good way to work on these check your understanding problems, now that I've read the prompt and you understand, would be to pause here, to try numbers 1, 2, and 3 on your own, and come back and have me do the explanation. You could also break it up, right? So you could also pause it here, do number 1, listen to me do number 1 for myself, and to explain it to you, then pause and do number 2, do the same thing for number 3. So any way you slice it, a good practice would be to pause it here, try it, one portion or all of it on your own, and then come back and listen to my explanation. Okay. Number 1, describe how to select a stratified random sample of 300 pencils. Explain your choice of strata. Explaining choice of strata and using a stratified random sample involves looking at the prompt and seeing what are the most significant details that might lend themselves to giving us stratification, or what in the problem tells us, okay, I should divide this here because this is a logical place where I would have to divide my groups into strata. In this case, the factory runs 24 hours a day, but there are 3 8-hour shifts. for me, that's going to be my strata. So my strata, in this case, is going to be for each shift. And that would be day, evening, and night. Okay, day, evening, and night. What I'm going to do is I'm going to choose 100 pencils. Okay, so I'm going to choose 100 pencils from each shift. Now, because it's stratification, I just said I need 300 pencils. I'm using 3 strata, so I'm going to divide the total number of pencils that I need into my number of strata. So that would mean 100 pencils per strata. So then now I need to describe, so I explained my choice of strata. And I want to describe the process of selecting a simple or stratified random sample. So what I'm going to do is, number 1, label all pencils 1 to N. And for number 2, I am going to randomly choose, and I should say 1 to N on each shift. Okay, so 1 to N, so during the day shift, from 1 to N, number of pencils made. Evening shift, 1 to N, number of pencils made. Night shift, 1 to N, number of pencils made. Randomly select, so randomly choose 100 different numbers. Okay, so randomly choose 100 different numbers, and I'm going to say exactly how I do that. So random number generator 1 to N and 100 of those. And my third step is going to be select those 100 pencils. And maybe my explanation is a little unclear here. So what am I going to do? Am I going to use the same 100 random numbers for each shift? No. And so I probably should make that a little bit more clear here. So label all pencils 1 to N, randomly choose 100 different numbers, random number generator from 1 to N, 100 numbers, select those 100 pencils. And the key here is going to be to say repeat for each shift. So that means you'd start it again at the end of the second shift and label them 1 to N, do your random number generator to pick 100 numbers, then go back and pick those pencils from your 100 numbers. Okay, so that is a stratification, stratified random sample. How do we do clusters? So how to select a cluster of 300 pencils. So explain your choice of clusters. So for my clusters, my boxes. My boxes are my clusters. Why did I choose that? Well, those are little groups that they're naturally broken into, because up here it says they are packaged in 10 boxes, packaged in boxes of 10 pencils each, which would mean I need a total of 30 boxes. So for this cluster sampling, what I'm going to do is, 1, I'm going to label every box at the end of the day, 1 to N. I'm going to 2, randomly select $30 different numbers. And for that, I'm going to use a random number generator from 1 to N and 30 numbers. And number 3, check all pencils in those 30 boxes. Okay, and this is key here. So if you're ever describing, like I said up top, if you're ever describing a cluster sample and how you're going to do it, you need to explicitly say, I'm going to sample all of the things in that given cluster. In this case, the boxes, all the pencils in those 30 boxes. So what are some examples, what are some benefits of using the stratified random sample and the benefit of using a cluster random sample in this context? Well, the benefit of the stratification is we get 100 from each shift. Okay, so we get 100 from each shift. so it is a more precise estimate of quality. Because I have 100 from each shift. So I have an equal number from each of the 3 shifts. And so that's going to give me 100 pencils from each shift. Great. Better overall view of what the quality is. A benefit of my cluster sample is that it simplifies the process. Okay? We don't label every pencil. Okay? You don't label every pencil. You don't have to designate all the pencils each box. So just okay, so we just label every box. All right, so those are the benefits of that. That's sampling methods day 1, guys. We talked about 2 of them, a stratified random sample and a cluster sample. And so as you're looking at designing these experiments or designing these observational studies, those are the types of things that you can use to break up a group and make sure that you are representing each group of individuals in the population when you're trying to select equally using that random sample, okay? So thanks for watching, guys, and we'll see